Okay, good morning, everyone. Thanks for coming in, and thanks for inviting me to present this talk here. So we're going to talk about building network equipment and a business using free software and liberated hardware. Before we start, a little bit about myself. So I'm surviving on free software for 18 years, more than 18 years now. And I had been a Debian localization contributor for Debian installer. I contribute to OpenStreetMap as a volunteer mapper, and I have also contributed a little bit to the OpenWRT project. And since 2010, I'm running a free software business called Unmukti Technology, where we build network equipment and provide services over those equipment to small and medium enterprise. So, as we all know, we live in a connected world. This is an example of a smart home, which has all the devices that you can imagine, which makes the home smart. So, to start with, you have handheld computing devices that you call your mobile phones. You have voice-operated virtual assistants like Amazon Alexa or Google Home. There are various home automation systems. You have audio, video, media players, Internet of Things devices, maybe many more kind of devices which actually need network to talk to each other. And then network needs equipment to function. What kind of equipment network would need? Say, for example, routers, wireless access points. You may need network security appliances like firewall or intrusion prevention systems. If you look at an enterprise network, so you may encounter network access controllers. Then network attached storage can be found at home networks and enterprise network as well. And then you might find VoIP phones at your work networks. So we live in a world which is connected, and then we are surrounded by black boxes. Right? So most of the equipment which you find in your surroundings, they are mostly black boxes if they do not run a free software. So those black boxes are probably surveilling you. For example, your mobile devices, or you must have heard about the recent controversy with Google Nest Secure device. So, for example, it had a keypad to secure your home networks, and when Google released an update to Google Assistant in January, in the press release they said that Google Nest Secure users can use Google Assistant with Google Nest Secure. Now, to use Google Assistant, you need a microphone on the device. But that particular device just had a keypad and some actuators and sensors. So what is a microphone doing on that device? Google says that was an oversight while creating datasheet and technical specifications of that device. So those black boxes are actually black boxes because you do not know what manufacturer has put in. So what is a black box? Black box is a sort of any equipment which manufacturer does not want you to know how it functions or what runs inside it. They just want you to know, okay, this is the function and you can use it for that particular functionality. So most of the smart black boxes, they are essentially a computer which are running a locked down hardware and most probably non-free software. So they do not let you run free software on them by design, either free software or the software of your choice. So the vendor controls their usability, their upgrade, and their support. So the day vendor decides that those particular equipment would not be supported, or it becomes a liability for them to support it, they can suddenly decide and then declare it end of life. So that particular equipment becomes a paperweight for you because you cannot change the software, but you know that it's a computer. Let's talk about network equipment. So if you look here, the first line says the products are licensed, not sold. So for example, if you have bought a commercial network security equipment like a UTM from a proprietary vendor, that equipment is not sold to you, it is licensed to you. And they charge you for the usage, say for 1 year or a 3-year duration, and then you have to renew those licenses. Now what happens when you do not renew the license? The functionality is crippled. You cannot use all the functions of that particular equipment. Vendor will not provide you security updates or further software updates unless you renew the licenses. Now, if you see the limitation of use clause, the font is really small. I'm not sure if you can able to see it. This is a screen grab from end user license agreement of a very popular network security equipment vendor. So it says you shall not attempt to, and if you're a corporation, you will prevent your employees and contractors from attempting to modify, translate, reverse engineer, decompile, disassemble, create derivative works based on license, or distribute the products, including without limitation the firmware of the accompanying documentation. So, which is totally against the free software philosophy. So they are curbing all your rights. Your rights are crippled. You cannot repair, you cannot extend, you cannot repurpose it once that device has stopped serving its purpose to you. When we talk about repurpose, all right, so before talking about repurpose, let's see what those proprietary equipment run. So most of them either run BSD, Linux kernel, or some part of the GNU operating system, or maybe other accompanying free software to provide functionalities or features to you. And a lot of them violate free software licenses. Yesterday, someone was talking about GPL violations and its effect on OpenWRT. So Cisco Linksys had violated GPL licenses, and when Linksys was sued and forced to release source code, the project called OpenWRT had won. Earlier, some vendors were sued for using IP tables or NetFilter in their products without releasing the source code. So a lot of them violate free software licenses, and this is again the screen grab from the same end user license agreement which we seen in the previous slide. This particular company was considered a GPL violator for a very long time, and once they were acquired by another company, they included all this information in the end user license agreement. So I haven't bought any product from them, so I do not know whether they provide the source code, but you can see what all software or free software they are using in their firmware. So even they are using ARP tables, BusyBox. You can see IP tables, IP route 2, Snort. Snort is a very popular IDS and IPS software, right? OpenVPN. OpenVPN is there for creating SSL VPNs in their equipment. So it's using a lot of free software, a lot of software which is in public domain as well. But this company was not releasing the information earlier, maybe 10 years back. Now this information is available. So do we truly own such devices? Maybe not, because of signed kernels and TiVoization. So TiVoization is a concept, is the word coined by RMS. So TiVo was a I don't know whether it is still popular, but it was a media playing device, and it runs free software. But the hardware is designed in such a way that you cannot replace its firmware with your own firmware. So even if it is running free software, you cannot run your own free software on it because it is looking for cryptographically signed kernel. So again, you do not own that device. Now, if you own a device, you can repurpose it to whatever way you want to use it. For example, this was an off-the-shelf cheap wireless router, which was repurposed, and in the USB slot, we connected an audio card, and this became part of a mesh network of a community radio station to access the community radio broadcast over wireless mesh network. Now, if we replace that USB sound card with a USB webcam, and we run MJPEG Streamer, very popular and small software that can stream from a web camera, you can very easily create an IP camera for monitoring your assets, right? So this equipment or this particular device, we were able to liberate it for our usage, right? So we have already liberated our computers, like your laptops, your desktops, to some extent our mobile phones, and there are a lot of free software options to create Internet of Things devices. For example, you can automate your home using ESP8266 boards, which can run MicroPython code. Now, regarding computers, a lot of laptops have proprietary BIOS. So that particular BIOS prevents you to install additional cards which the manufacturer does not want you to use. For example, you have bought your laptop from a company called X. So you can only install additional cards in the MSATA slots, not MSATA, but yeah, Mini PCI Express slots, which are approved by that particular vendor, and you get those cards at a premium because all other cards are blacklisted in the BIOS. Now, if you are able to replace your proprietary BIOS with a LibreBoot or Core Boot, you can install whatever extension cards you want. But have we liberated our networks? Because the laptops, the mobile phones, they are the devices which we interact with at personal level. But do we care what equipment is powering our network? I mean, we have Wi-Fi access here available, but did we care to find out what kind of equipment is providing wireless access to us, whether it is snooping on our traffic or not, whether there is a deep packet inspection device installed on the network or at the edge of the network, which is tracking and getting all the metadata. Maybe you have you're accessing internet use over TLS or HTTPS connections, but still metadata can be analyzed to track your activity. I mean, your destination addresses, destination ports, they can tell a lot of things about you. There is a service provider in India which has recently started their network, and before starting the network, they had mentioned this in an interview that data is the new oil, and they want to analyze data of their users to provide them, to know more about them and provide them personalized services. So I'm not sure what kind of personalized service is a mobile operator or an ISP is going to provide. So when we think of powering our networks, is free software the first choice? I mean, for example, if you have to buy a router for your network, what is your first choice? Do you care what kind of equipment you're buying? Maybe some of you might care, some of you might not. But the thing is, we should care about it. So now, all right, if we start caring, what equipment can be built using free software? A gateway router and a firewall is the most basic thing that one can build. And what is the simplest router? Any computer which is connected to more than one network and can route traffic between them, right? So a desktop with two network interfaces can work as a router and a firewall. Maybe your laptop can work as a router and firewall. For example, your wireless is connected to this wireless network, and you can connect a switch to your Ethernet port, and you can provide network connectivity to all other devices. Then your laptop is acting as a router. Or you can use certain single board computers which are available off the shelf. For example, this is PC Engine's APU. Anyone has heard about it before? Yeah. Good. So it's a Swiss company, and they make very good boards. This board is powered by AMD processor. It can have up to 4 gigabytes of RAM and a quad-core processor. And you can see that it has expansion slots, so you can connect whatever peripherals you want. I mean, for a simple router or a gateway, you would just need a storage on which you can install your firmware or your software. Apart from that, it has everything else on board. For example, it has 3 to 4 network ports. It also has USB connectivity. There is another board called Espresso Bin, and Banana Pi is a derivative of Raspberry Pi. So Banana Pi R1, for example, is an old variant of the router, but there is a new variant available, which I haven't yet got my hands on. So these are the examples. So if you explore the internet, you will find single board computers which can fit your requirements. What about software? So I believe most of you are GNU Linux users here, and any GNU Linux distro which has iproot2 or NetFilter and IP tables can very easily work as a router and a firewall. You might need some supporting utilities as well. So for example, if you want to intercept web traffic, so you might want to run a proxy server on the same device. So you might need Squid. So let's keep things simple first. So why are we reinventing the wheel by installing a distro from scratch and configuring everything when we have so many options available? LibreCMC, OpenWRT. Okay, so the middle one is IPCOP, IPFire, pfSense, OPNsense, Shortwall. So pfSense and OPNsense, they basically run over FreeBSD, while rest of the options, they use a Linux kernel and GNU utilities. So you can choose anyone. All right, so that was simple, right? You have a hardware and you can install a distribution and your device is up and running. You can build wireless access points. So OpenWRT and LibreCMC projects, they focus on building wireless access points. So you can buy off-the-shelf access points available in the market, which are supported by these two projects, and you can flash them with the pre-built firmware provided by those projects. So OpenWRT and LibreCMC are basically full-blown GNU Linux distribution designed for embedded devices. So you can run a lot of things which off-the-shelf wireless router or access point is not able to run. For example, there's a small wireless access point available in the market which has 128 MB of RAM, 256 MB of RAM, 128 MB of storage, and few gigabit ports and a wireless card. So when we deploy it at small networks of our customers, we run OpenVPN on it, we run Squid proxy on it, we run firewall, we run multi-WAN load balance and failover on it. We can even failover the network to a 3G or 4G dongle. And yes, it also has wireless. But if you buy certain router from the market, you would not be able to run all those things on it. All right, so Tor, the onion router, we who care about our privacy and who we care about being tracked, they prefer to use Tor to add anonymity to our network traffic. Now, for individual devices, running Tor on individual devices in your network can be cumbersome at times, but if you can run Tor on the gateway itself, so whatever devices connect to your network, by default they are using the Tor network. So you don't need to configure Tor on each and every device, or maybe VPN on each and every device. So, I mean, when you have a full-blown GNU Linux distribution available to you, you can do anything that you imagine. So if you can imagine a gateway router with Nextcloud running on it, so you can have a home router which is sitting at the gateway, and the newer release of OpenWRT, it supports Linux containers. Now, when you can run Linux containers on that embedded device, or LXC, on top of that Docker is built, Kubernetes also uses that infrastructure. So it doesn't matter what the base system is, whatever software you want to run, resources permitting, you can run on that particular device without disturbing the base configuration of that particular equipment. So as they say, if you want anything to manifest, you just hold a thought for a while and it will manifest. So yeah, I mean, you can build whatever you want because the boilerplate and all the heavy lifting has already been done. So, and since containers are already supported, you can imagine and create anything for your networks. And then as you build, you should share with the community so that others can benefit from your work. So far what we have seen is like a typical hacker would do with the hardware, or a hobbyist would do with the hardware, or whatever we do at our home networks. So can free software be used to build high performance and scalable networks? From my experience, all the networks have just one complaint. Users always complain that it is slow, it's not performing, and network administrators are always going crazy attending to users' problems. Right. So most of this problem is the capacity issue. For example, everyone thinks that if they have to build an enterprise network, for example, if it's a small or medium-sized network of say 100, 250 users, they would just buy a box, a black box, a UTM, and install it at the gateway, and they think that, okay, it has solved all my problems. It will solve all my problems, but it doesn't happen because that box is running a lot of things. It is scanning for viruses, it is doing intrusion detection and prevention, it is also filtering your web traffic, it is doing firewalling, it is terminating VPN connections on it. So once it is overloaded, you have to upgrade that box to a higher capacity box. But if you separate hardware from software, you know parallel softwares in the free software world. So for example, if you take intrusion prevention system out of that particular equipment, because IPS software need to inspect each and every packet. So if you take that load off that equipment and put it on another hardware, your network will start performing again. Now, if the web traffic builds up, you can take the proxy server out and run it on another machine. So in order to build scalable networks, you have to isolate hardware from software, and only then you can scale. So you can put more machines for load balance or failover for the service which you find is experiencing heavy load. Now, for example, there's a very popular routing daemon called BIRD. It's Berkeley Internet Routing Daemon, and there is a software called Quagga. Both are free software, but the Internet Exchange Points are those points where multiple ISPs interconnect. So, for example, ISP A has to send traffic to ISP B. All the traffic will go through a certain IXP, and it will cross over. So they have to propagate thousands of routes between ISPs, but there they do not use any proprietary hardware. They run it on BIRD, and as per last report that I could access, BIRD had 64% market share of running routing daemon. Quagga was next, and proprietary hardware or software, it was less than 20%. So yeah, free software can be built can be used to build scalable and high-performing networks. Now the question is it possible to build a business that builds networks using free software? So we are doing that for, say, past 9 years. So there's a success story. There was a prospect which was facing a lot of problems, and when we went there and we installed a free software firewall, their problems disappeared. But the users were unruly, and they used to find new ways to break through the firewall. So since we had a lot of tools to our disposal, because it was a free software firewall and it was a full-blown distribution, Linux distribution, GNU Linux distribution, so we were able to come over all those problems. Now, from that experience, at one location of that customer, we are now able to manage more than 200 locations of the same customer. But there are failure stories as well. So we proposed a solution to a prospect. We were able to match 85% of their requirements. 15% were not being able to be matched. So he didn't like our solution. Why? Because we could solve someone's problem, but not everyone's problem. So we solved someone's problem, but we could not solve this other one's problem. And that is because we are using free software, and community creates solutions to everyone's problem, because they want to, community generally creates software which covers a superset of problems. Now, the 15% which was missing is because we have to solve that problem. There was a gap in that problem. There was a gap in the solution that we proposed. So we primarily assemble various free software components to provide solution. Now, that gap is because the other someone, he doesn't want to get his hands dirty. Now, freedom has a cost associated to it, right? Freedom has a cost, and it takes many years for people to realize that coffee tastes sweeter without sugar, right? So to fill the gap, businesses need to build solution which fills those certain gaps. Now, the free software business that we run, we have our hearts and minds in the right place. We contribute back to the community, we utilize what community has done. We also let our customers know what they are getting into and what their freedoms are, but they do not realize they're happy with the solution. Everyone wants solution to their problems. Now, the thing we lack is mitochondria. So our hearts and minds in the right place, but mitochondria is called powerhouse of the cell. We do not have that because investors are not excited about free software. A little anecdote, there was, Government of India has an organization called NASSCOM. They're running a project called 10,000 Startups, where they want to fund startups, 10,000 startups in a period of 5 years. So we were there. We were using free software. We were already solving problems, and we were already cash flow positive. But still, we did not succeed. So, from our example, Unmukti is just one company which is building customers' networks using free software. If you could imagine 5,000 more companies helping people build their network, enterprise network, because we are in an enterprise segment, enterprise network, you can just imagine what kind of world that would be. So that was all. If you have any questions.
If you have any questions, you can come up right to the microphone here. If you need a microphone brought to you, just raise your hand and I'll bring it up to you.
Thank you for the talk. It was very interesting. A couple questions. I guess first, firmware for wireless devices.
Right.
Do you have any tricks or tips for, especially anything that's an AC wireless device? Have you found anything that is free Libre firmware?
Well, if you are looking for 802.11 AC standard, you won't find hardware which is truly free, because the best one used to be Atheros chipsets. Now, since Qualcomm has acquired Atheros, it has become Qualcomm Atheros QCA devices, and those system on modules or SoCs, they have binary blobs associated with them. So if you want truly free device, you'll have to
Just use wireless N?
wireless N, yeah.
Okay. And older hardware.
Things might change in future. I mean, when the next standard comes, they will obviously release.
I hope so. I don't have a lot of hope for that, but
Yeah.
that's good to hear. And then also just wondering about security patches in general. So I think about like, Taurus Omnia.
Yes, Taurus Omnia is a very good example.
Yeah, exactly. Where they, I guess they use OpenWRT with a couple of patches.
Yes.
But their whole spiel is that they push security updates remotely all the time.
Yeah.
So I guess, do you have any best practices? I guess if you're just using a mixed distribution, you just auto-apply security patches?
For us, what we do is, over the years, we have learned how to compile OpenWRT and how to apply patches from upstream. So we know how to keep our devices updated. But yeah, OpenWRT or LibreCMC, they also do security releases or maintenance releases, which is anyway better than buying a proprietary hardware where vendor doesn't provide you updates after 3 years or 4 years.
Okay. Do you have some tools for automating those security patches, or do you just go to each customer every time with a flash drive?
No. So we have done a lot of hacks. So they're not elegant, so that's why we have not put it out for the world. But yeah, we actually want them to be pushed out so that we get to know the feedback and it can be improved a lot. So typically, I'll tell you, we used to do it by Dunkey method. So SSH into the devices and then upgrade the firmware. But now we are trying to use Ansible and do things like that. Just
No? Okay. Have you any experience setting up like true mesh networks? And do you have any preferred software or
Well,
tips for doing that?
yeah, so we tried to set up a L2 mesh using Batman.
What was it?
Batman
Okay.
Batman is a part of OpenWRT. So it works for small networks if you have small devices, but since it's a layer 2 mesh, you get lots of layer 2 broadcast traffic, and that it tends to bring the network down. So after that, we did not do layer 2 meshing, and no customer has asked us for layer 3 mesh networks as yet. But I hope if someone comes up with a larger warehouse, we would be able to set up a layer 3 mesh. So honestly, I cannot give you any advice on that.
Okay, great.
But yeah, only advice is do not use L2 mesh.
Okay. Thank you.
Thanks.
So another question about modems, I guess. And did you run into troubles with modems? I know that some things I run into sometimes where I've had a couple of problems is working with the Verizon network where they run over fiber optic, and there's some kind of hard things converting that, but I guess there are other standards for the coax modems, but I guess.
Yeah, so we have made a thumb rule. We ask ISP to configure their device in bridge mode, so that if it's triple PoE, we do authentication. If it's a static IP assignment, it is assigned on our box. So that way, ISP just has to bridge our device with the network. So that also saves you from further headaches, because ISP's devices have less amount of RAM, and they have some stupid kind of rules where number of connections, if they increase and the contract table fills up, because NAT is being done by ISP's router, and contract table fills up, your network will start freezing. Now, when you are having your own device, you know that you have a lot of RAM, and you know what traffic you have to NAT, what you do not have to NAT, right? So it is much better to fill your RAM or have your device do the actual NAT with more system resources than an ISP's device.
So then when you talk to them, and the ISP work with you in order to set up this?
Yeah, so when the technician comes,
Yep.
just ask him to configure the ONU. Generally, that small fiber device is called ONU, which converts your light traffic, optical traffic to Cat5 or Ethernet, right? So it can be configured in bridge mode.
Okay.
Yeah, Sam. Sorry.
Hello? Is this? Yep. Okay. This is Sam Hartman. You may run into one problem with that, at least in the U.S., where they want to run both an Ethernet network and like a MoCA network, and if you're in that situation, you run into some awkwardness because so you've got this thing being a bridge, but it really wants to only have one device behind it now, typically. And so if you're trying to have two access technologies, you can run into trouble at that point.
Two access technologies, for example.
MoCA and Ethernet. So at least with Verizon, they want to run a MoCA network in the premises as well as an Ethernet network. And if their device is in bridge mode, it's really pretty hard to do that.
Okay, so I haven't encountered a MoCA network in India as yet. So is this something new or typical to the US, or?
It's not new at all.
So I'm sorry, I do not have an answer to that. If anyone else. Because most of the networks that we have encountered, they have just one technology. So it's either fiber or copper or say radio. But ultimately we get an Ethernet termination over that.
Okay, that wraps up the time we have for questions and answers. Thank you, Nishan.
Thank you. Thank you for having me here.